I'm Doug Sillars. I'm originally from Seattle, Washington, but I'm traveling with my family. We're based in Dublin for the summer. And so I talk a lot about mobile performance, and we've had a lot of really great conversations already about mobile and performance so far in the last 2 days. But I'm going to focus mostly on images and video and how we can deliver images and video in a way that are beautiful, but is also fast. But before we start in on that, how many of you look at this picture of this walkway out in the Alps and get a pit in your stomach when you think about walking out on the edge of that cliff? Anybody? Like, it's a little terrifying, right? I walked out on that with my family, and my kids were terrified, except for the 6-year-old who jumped the whole way, rattling the whole thing. So a year or so ago, Ericsson did a study where they put sensors on people's heads to measure stress levels of different experiences. And they found things like standing in line raises your stress level, right? You're in line, and there's so many things to worry about. And they found that standing on the edge of a cliff is terrifying to many, many people. But they found that a slow mobile experience is actually more stressful than standing on the edge of a cliff. So that pit you guys all just felt in your stomach, that's what your users feel when you build a slow mobile experience. And so we've had a lot of stats. We've already talked about Google, 53% abandoned after 3 seconds. People get frustrated. We talked about Amazon and Walmart and how people spend less money when things are slow. But also importantly, 4% of mobile users admit to throwing their phones when there's a slow mobile experience. So these are things we want to avoid. When you see someone with a cracked screen, it might be your app that caused it. So what can we do to speed up a mobile app or a mobile website? Well, if you look at the HTTP archive, and the HTTP archive looks at the top 500,000 sites every 2 weeks, they find that the average website is 50% images and 25% video. So if we can optimize the delivery of images and video, we're going to speed up our websites. So how many of you heard of Lighthouse? Chrome DevTools, like, it's a great tool to understand. It runs tests on how to improve performance of your site. And I'm going to talk about 4 image optimizations that are in Lighthouse. Lighthouse 3.0 has a few more, but I'm going to focus on quality, format, sizing, and lazy loading. And inside Lighthouse, when you test your website, you get graded on these, and you're graded from a score of 0 to 100. 100 is good, 0 is bad. So the cool thing about all of this is web page test fans, anyone? You should all be using web page test. It is an awesome free open source tool, and it helps you test your web page. Oh, there we go, web page test. Sorry, web page test fans? Oh, webpagetest.org, everybody. Test your website on it. It's a really, really great tool. They have browsers of all different types and devices all around the world, so you can test your website all around the world to see how it performs in different places. Well, the HTTP archive is built on top of web page test, and web page test does a Lighthouse. So I can, in the HTTP archive, every 2 weeks, we get Lighthouse scores for the top 500,000 mobile websites. So we can look to see what the status is of the web of these 4 optimizations that I was just talking about. So let's start with image quality. So what's image quality? You know, this is in preview, right? As I move the slider, you can see the file size gets lower as I go to a lower quality. So when you save a file at lower quality, it's going to be a smaller image. Unfortunately, it also looks worse. So where do we go? What's the right quality to use? Lighthouse and Google recommend 85% quality on all images you deliver on the web. So how do you do that? In ImageMagick, you can just set the quality to 85. You take your Riga JPEG and save it as Riga 85, and you have a brand new image. With like a cloud service tool like Cloudinary, you upload the full-size image, and then you can just change this parameter in the URL, and that will deliver a quality 85% image. We can look at this in the HTTP archive and see what people are doing. And what we see is 40% of the web is doing it right, but a full third of the internet is not serving 85% quality images. So there's a huge room for improvement here. On top of those stats, Lighthouse estimates how much faster your website will be on 3G if you implement this. The median website that gets a 0 will be about 3 seconds faster on 3G. It'll be even faster on a slower connection. A lot of the world is on a slower connection. And you will save about 400 kilobytes of data, median. So half the sites will save more, half will save a little less. What does a change in quality look like? This is a photo I took yesterday. 3.6 megabytes, full size. When I save it at 85%, I have the size of the image, right? It's gone down from 3.6 to 1.8 megabytes, and it still looks great. But can I squeeze a little bit more quality out without anybody noticing? I can save it at 50%, and the URLs are down here. It's kind of hidden in the buildings. But it's a very complicated image. We could get down to 900 at quality 50. Quality 20, I don't know if you can see it, but there's banding in the sky. Can you see the banding in the sky? It looks really bad. We wouldn't want to serve this 500K image because it looks bad. So we can look at what it looks like. We know Google says 85 is okay. We've already saved 50%. That's huge. We know that 20% isn't so great, but what's in between? Can we do better without manually looking at every single image? Because, you know, we all have thousands of images, potentially thousands of images on our website. Well, luckily, there are tools that will do that. It's called Booter from Google, because all Google's compression folks are in Switzerland and they name things after pastries. And structural similarity is another tool that you can use. And so here's an open source tool, and I ran it and I created. And what it does is it finds the sweet spot where the human eye can't see a difference, but it's lowered the quality to just the right amount so no one can tell a difference. Inside a tool like Cloudinary, instead of Q85, I say Q Auto, and it automatically on the fly creates that does a structural similarity on the image. And when I do that, it's 1.46 megabytes. And if you remember, the 85 was 1.87, so I saved another 400 kilobytes. Just by doing this extra step. You can see, you know, I made an improvement. It's another savings in data. But as we've talked about, it isn't necessarily just data savings. It's like, how fast will this load? So web page test, there's the website. I've chosen to run this in Dulles, Virginia, because they actually have devices. So I'm running it on a Moto G4 using Chrome. So this is a real device. Over Wi-Fi, I throttled it to 3G, and you can see the full web page, or the full image, takes 21 seconds to load, and that's horrible. When I take it down with structural similarity, I get it down to 9.5 seconds, so I've made it twice as fast. You know, and obviously the number of bytes has gone down by a whole lot too, so we've really improved the performance of this image already. So what's the next step? Let's look at the format of the image. And so again, HTTP archive, this is average file size for different formats. JPEG is the largest at almost 50 kilobytes on average per JPEG. We had a great talk earlier this afternoon about SVGs. They're the smallest because they're XML-based, they're text-based. So they're really great for things like icons and very simple images. And here's an example SVG I found on the internet. You may recognize this logo. The problem is this company did the right thing. They created an SVG logo of the Facebook icon to put on their web page. It's XML, but look at this bit down here at the bottom. I zoomed it out so you can see it. You see the little red text over there, Adobe Illustrator? And then look where the little thumbnail is right here. 1.3 megabytes of Adobe Illustrator cruft. So I went into the XML and I deleted it, and I resaved it. 900 bytes, and then I compressed it with gzip and Brotli. I got it down to 440 bytes. So Brotli is a new form of gzip by Google, and Brotli is, of course, a small bun in Switzerland because they name it all after pastries. Anyway, so let's look at other formats that are out there that are more for images like photographs. And WebP, the purple one here, you can see is a lot smaller than JPEGs. So let's look at what we could do if we used WebP as an image format for our web pages or our mobile apps. Now, the biggest problem with WebP has been that it's a Google format, and if you look at can I use it, it works really well for Google tools, right? Chrome and Android, like, we're good. but the rest of the internet hasn't been so great. So people do things like JPEG 2000 for all the other browsers, but then that gets complicated because you have JPEG 2000 and WebP, and then JPEG as a fallback. And that can get really complicated. But about 2 weeks ago, this changed down in the notes. Safari and Firefox are experimenting on it, and it's in development for Edge. So really, really soon, we might be able to do WebP on most of the internet, which is really exciting because it's a modern format. It's only about 5 years old, whereas JPEG was introduced in the 90s. Like, it just compresses better. So if I take that same image, it's now 900, 1,000 kilobytes, about a megabyte, when I add the WebP to it as well. And with Cloudinary, all I do is say set the format to auto, and it automatically creates the right format. And so what we see here is I took it from 9.5 seconds down to 7 seconds load time. So we're improving the delivery of this image. And what's great is, again, there's no loss in obvious quality to the human eye. So for us as humans, we can't tell that this image is any worse than that 3.6 megabyte image I took on my phone yesterday. Now, when we look at image format use in the HTTP archive, no one's doing it. 2/3 of the internet score is 0 for this. So again, obviously it's only in Chrome. The HTTP archive is testing on Chrome, so if it was there, we would see it. Using this, if we look at the median website, will be about 4 seconds faster and use 600 kilobytes less data by switching from JPEG to WebP. That's a huge potential savings. So again, this is another way to just speed up your website, speed up the delivery of the content without anybody even noticing that you've done it. Sizing of images. So that image I took in Riga was a 13 megapixel image because that's what my camera takes. This is a different image, but you can see the original image was 1.6 megabytes. I did the structural similarity, I did the WebP, I got it down to 800 kilobytes, but if we look at the dimensions, it's a really big image. It's 13 megapixels. And you start thinking about a mobile phone, and we know that it's not going to be that big. So we're wasting a lot of data. Because what happens is the phone downloads 800 kilobytes of data, and then the CPU has to fire up, and it has to throw away 12.4 million pixels. And so on a lower end phone, the CPU heats up, the battery drains out, right? This is all horrible stuff to do, and it takes a long time on a low powered phone. So you get taxed downloading it, and then you get taxed processing it to get it up on the screen. And the only analogy I can think about that's similar to this in real life is when you order something from Amazon and it's got like 15 feet of brown paper inside the packaging, and there's like a pencil in the bottom of the box. We waste a lot of the data that we send over the internet, and we could make it more optimized. Now, the problem, of course, is these are the Android phones that hit Akamai in one day. There's 6,600 different phones listed here, phone types. The size of the box is how many of each device that is. So these are all Samsungs, the big green boxes. Green means it's got a fast processor. Orange, yellow, red means that they're slower. The smaller the size of the box means that there are not a lot of them. And you can see there's a lot of red as you make your way down to the event horizon in the bottom right. So how do we optimize for 6,600 different devices? And that's just Android, right? We're not even getting into desktops, TVs, tablets, anything else. So on the web, we use responsive images, right? And the going theory is you set up a bunch of images that are 25 kilobytes apart. And so I ran this through a tool. I got a bunch of different sizes. I picked the one that was just slightly bigger than my screen, and you can see now I'm only throwing away 100,000 pixels, which is pretty good. It's less than 25 kilobytes. I know that because they're all 25 kilobytes apart. And there are a lot of really great tools that will help you generate those images. This is a tool called responsivebreakpoints.com. And you upload your image, you set all the parameters, you hit go, and you get all the images processed for you. You can do this as part of your upload process, all sorts of different things to optimize your images. And you get something that looks like this, and this is a bunch of code, but you can see for different widths, I've got different images. I'm just going to point out right here, I'm using, again, Cloudinary because it's really easy for samples, but I've got the quality set to auto, and then I can this parameter in the URL is changing the width of the image. So it's delivering an image of, right here, a width of 693. Notice also that every other image has a sepia tag to it, and that's because it makes a really cool demo. So this is that responsive page that I just built, and as I change the size of the screen, you'll see the different images load for the different screen size. If it works. There it is. All right. So every time I do this, this is a new 25 kilobyte image loading. And so you can see there are a lot of them. On a little tiny phone like this, it's going to look great. It's going to be like 20 kilobytes. On a really big screen, it's going to be more kilobytes, and it's going to look really, really great, but we're not wasting that data on smaller phones. You're not downloading those giant images. And then this slide is the video in case my internet connection didn't work. All right, one more click. Okay, so where do we do when we do a responsive website? So now it's getting a size of the image that's designed for a Moto G4, and you can see now we're down to 2-second load time, and we went from 1 megabyte to 120K. So we've really, really improved the quality and the speed of the website. Again, no detriment in image quality. So responsive images are used a lot more than all of the other ones I'm talking about on the web, and I think this is mobile first. So a lot of companies said, we're going to go mobile first, we're going to resize all the images, so about 60% of the web is doing this right. But there's still room for about a fifth of the web to do a lot better. For that fifth of the web that isn't doing it, the pages could be median web page at 3G will be 2.7 seconds faster and save about 400K. Okay, so everything I've talked about so far is loading one image, how to optimize one image at a time, but let's talk a little bit about lazy loading. So this was a study that was recently done based on how people browse the web. And what they found is that 57% of people who go to the web don't scroll down. They just look at the first viewport of the screen, and then they don't look any further in your web page. So if your web page is loading images that are 6 or 7 viewports down and no one ever sees them, could we not load them and then make the page load up a lot faster? So, the example here is this website that I've built that has 6 images, only 2 of them show up in the viewport. What if I hide 4 of them, right? The fastest thing to load on a web page is the thing that you never download. All right. Lazy loading, not used very much in the wild. 60% of the internet is scoring a 0 on that. And lazy loading has huge performance. Again, 3.5 seconds median improvement on 3G and another 530 kilobytes. But what do you load down here? And we've talked a little bit about this in some of the other talks. There's a lot of movement now towards skeleton frames and preview images. Here I'm searching for cats in costume at Google Image Search, as one does. And you can see, an orange frame comes in for the cat wearing a pumpkin costume and the green for the alligator, et cetera, et cetera. You can also use SVGs for this. There's a tool called Squib. The URL is down there. I created an SVG representation of the waterfalls. And so you could put that in as a placeholder. It's 900 bytes, uncompressed, 400 or 500 bytes zipped. And you can put that into place, have that show up immediately, and then when this image loads, it replaces it seamlessly. And what we find when we take a web page that takes about 4 seconds to load, and then we lazy load it, we remove a bunch of images down low, we half the load time. Preview images, it makes it a little bit bigger because now I have these SVG text, right? So it's 2 kilobytes bigger, but it's about the same load time. It says faster, but 150 milliseconds. We should probably do more experiments than I say definitively it's faster. All right, everybody loves GIFs. And GIFs are everywhere. If you read the original spec, you're not supposed to use, where am I here? You are not supposed to use GIFs. The spec says we have animation in the GIF framework, but we don't recommend that anybody uses it. It's in the spec from the 80s. And so I took this movie of my goat, Nora, 1.4 megabytes. I turned it into a GIF because the world needs more goat GIFs. The problem is it's now 3.8 megabytes because what GIFs are is a flip book of images. There's no compression through the time dimension. So it'd be better if I could make it 256 colors and a movie. I strip out the audio channel too because GIFs don't have audio. And the sound of a goat eating a leaf is a little disturbing. So what can we do? We can serve this in a video tag. When you serve it in a video tag, you have to put in loop, autoplay, and muted. Why muted? Because in Safari and Chrome, a video won't autoplay unless it's also muted. This is the save your ass in a meeting when you're browsing the internet. So it doesn't play the movie on the web page that you're looking at. Plays in line is to make it run in Safari, and then it'll play the movie. The problem with this is that videos are the last thing to download. It's the last thing that are loaded on a web page because they're big. However, in Safari, this just launched, you can now put movies in the picture tag. And why is that cool? Now I can loop an MP4 in the picture tag instead of the animated GIF. And if we look at the load times, the animated GIF is 3.8 megabytes. The animated WebP, which is WebP has an animated format as well, is 3 megabytes, but the looping video is just 250K. So if you can do that for your Safari users, that is going to load up a lot faster. And that sort of brings me into video. Video is, according to web page, to HTTP Archive, about 25% of the internet. And everything that we've held for loading pages fast, for loading images fast, it all holds for video too. This company came up with this idea of buffer rage, where people get mad when videos don't load. And we all know that when people get mad, they throw their phones. So what are the metrics that people use to judge video? And you're going to laugh, because I'm distilling it down into 3 metrics. The first metric is, did the video start? Seriously. The second one, did it stall? And then the third one is, did it look good? Like, this is what these are the metrics that people use looking for video. And so here's some data from Conviva from Q1 of this year. And this is looking at video starts. And 2.3% of all videos, this is 16.9 billion video plays around the world, 2.3% never started, and 11% people abandoned before the video started playing. So, 86% worked, but 2.4 billion failed to work. And that's a huge opportunity for us as developers to make sure that this works. They estimate about 800 million hours of video playback were lost. So what can we do? Let's look at failed to start. And I have a couple theories, but I think probably the biggest one is this one, right? You get to the web page, you're like, oh, I want to watch this. And then it's like, you can't watch it here, sorry. To make it worse, to get to this page, it was 3.1 megabytes and 231 requests to tell me that it isn't available in my country. All right, we know what we need to do there. But let's look at videos that were abandoned before start. So, why do people abandon videos? Again, it's why do people abandon websites? It took too long. And so the data shows that the average video start time in Europe is 4.3 seconds. Now, an average is a really loaded term because this is mobile, it's desktop, it's 4G, 3G, 2G. I mean, it's everything thrown into, this is just one number. You've got to figure there are a lot of people that took a lot longer than 4.3 seconds. And so we know people abandon websites when things are slow. What happens with video? And Akamai did a study. Basically, everybody will wait for 2 seconds. But every second afterwards, you lose almost 6% of your viewers. So if it takes 4.3 seconds in Europe, you've already lost over 12% of your viewers if there's a 2-second delay. Now, there's 2 different types of videos that people watch on the internet. There's the short video, like the cat in a shark costume on a Roomba chasing a duck. Anyone seen that movie? Right? So movies like that, if it takes more than 2 or 3 seconds, you start questioning your life choices, and you abandon watching the movie, right? You're like, what the? Okay. But if it's a movie or a TV show and you know you're going to spend 15, 20 minutes, you're more than willing to wait a little bit longer. So people will wait longer. That's the red line there. So what can we do to reduce this delay time? And here are a few examples that I've encountered. This is from a native application where third parties got in the way. Tracking, right? Marketing wants to add another tracking beacon. This is going to be fine, right? So I'm watching a movie. The first thing that happens is an ad. We all don't like watching ads, but we know it's part of the process of watching stuff on the internet. And this is a tool that actually is looking at all the packets coming in and out. It's called Video Optimizer. It's an open source tool. I've got a link at the end of the deck so you can see it. And these two lines right here are the packets going back and forth, and the red line is the throughput. So we know video is a lot of throughput. So what's happening in these first 2 seconds right here when there's a lot of packets going back and forth, but there's not a lot of data. There's no video being transported. Well, we can look at all the TCP connections, and the blue line up at the top is when I started watching the video. And we can see down here, that's the line that has the video because the byte count is 4.9 megabytes. That's the video because it's big. So what are all these connections in between? It turns out these are all analytics. So remember physics where Heisenberg said the more you look at a system, the more you disrupt it and you can't actually measure it properly? This is the Heisenberg uncertainty principle, like in action, right? They're monitoring it so much, it's actually delaying the outcome. And I was able to measure this, and in a really fast connection, the blue line shows that there's a 2-second delay before an ad packet can be delivered. Not shown on the screen, delivered to the phone. And then down below 5 megabits per second, it takes up to 4 seconds for the ad to be delivered to the phone. Orange line shows it could be up to 12, 15 seconds before it starts playing, right? This is a huge delay, and no one wants that huge delay. I'm going to pick on this same application a little bit more. I slid down a little bit further. You can see the ad still on the left. The ad is playing in the middle where there's not a lot of packet traffic. And then when the ad is done, the app starts downloading the video. Well, what do you think happens when it starts downloading the video? We get another spinner. And that's horrible. What if you started preloading that while the ad was playing like that? Then the video will be there. It'll be downloaded in the buffer and ready to play when the ad stops. So preload is great when it makes sense, but be careful with preload. So this is a website. This is web page test. This is the waterfall of all of the content being downloaded. They had a video, preload equals auto. It doesn't play, but it's preloading the whole video. So the end of the thing, these are all the video packets being downloaded. Everybody who sees this web page, whether they press play or not, gets 23 megabytes of video delivered to their mobile phone. That can be very painful for people on limited data plans. So on pages where people aren't necessarily going to watch the video, you need to make sure that you're not downloading the whole video because that can be very, very wasteful. So we're getting close to the end. I'm going to talk a little bit about video streaming. So video streaming is huge. Cisco says that 75% of the internet traffic is going to be video. The first thing that happens when you deliver a video stream is you get a manifest file. It lists all the different bit rates and streams that are available. The player picks one, starts downloading it, the buffer fills up, and the video plays. But let's look a little behind the scenes at what happens. This is an example manifest file that I built. And what the player does for HLS is it always picks the first stream. That's the one it picks to play. And in this case, the bit rate is 8.5 megabits per second. What do you think is going to happen on a mobile phone for a video stream that's 8.5 megabits per second? Any ideas? It's going to be ugly, right? So what happens is the player chooses that 8.5 megabit stream. It's trying to download. It takes a really long time to fill up the buffer, and the video doesn't play. And so the player's like, this isn't working. It switches to a lower quality video, 192 kilobits per second. So if we graph the different bit rates, it starts there on the left, and it jumps all the way down to the low quality video. After it builds up the buffer a bit, it jumps to a middle of the number 4. It's 3.5 megabits per second, and it looks good. But there was a huge delay making that path to download all of those things. So what can we do? What if we reverse the order? So instead of having 8.5 megabits per second first, let's do the 192 kilobits per second first. Now, this gets the quality of video, right? The first couple seconds is going to look really choppy and pixelated. What happens is the player starts downloading at that low bit. It starts playing really quickly. It realizes there's more network throughput, and eventually it makes it all the way back to that 3.5 megabit per second stream. You've seen this when you're streaming video and the first couple seconds is really choppy, and then it pops into a really nice stream. They're doing this. And it's that trade-off. We want it to start fast, and then in a couple seconds, it'll look really great, sacrificing the first few seconds. Some streaming companies like Amazon do the Goldilocks approach. Not too small, not too big. They pick one that's just right. And in this case, when I run it with the first stream being 3.5 megabits per second, it starts right there and it goes. We can look to see what that looks like in web page test. And these are thumbnails of the screen. You can see when you start at the lowest bit rate, it starts playing at 11 seconds. At the highest bit rate, it starts playing at 17 seconds. There's 6 seconds different in startup time based on this. If we look at video in the wild, we can see that most of the web is doing it right, but still there's some people that 5% are not. So there's room for improvement there. So I'm out of time. I'm just going to skip ahead to the end. I've got a bunch of stuff on stalling, but we can talk about that in the open space next. We're talking about web performance if you're interested. So in summary, web page test, HTTP archive, a bunch of the tools I used, Cloudinary is where I was doing the examples. Images and video can be beautiful and fast. And I was running through some of this stuff with Cloudinary, and they offered to give a contest. And so the contest is I built a really slow web page. It takes 19 seconds to load, 11 megabytes. Get my code, submit it, make it faster, and the fastest website can win a €100 Amazon gift card. I got this web page down to 0.2 seconds. See if you can beat me. That's part of your challenge. You don't have to beat me. But anyway, thank you very much. I know I'm out of time, so thank you.
Thanks for the awesome presentation.